Good morning to one and all. In this video, mainly we are going to discuss about the embedded firmware development languages. Okay, so there are two different types of embedded firmware development. So languages. So that means uh, here mainly we focused on assembly language in this video. Okay, so there are two types of languages here. First one is the assembly language, and second one is the high level language. So the high level language can be a subset of C, that is called embedded C, subset of C++, embedded C++, or any other high level language with supported cross compiler. We define the cross compiler later. And the another possibility is the mix of assembly and high level language. So that means mixing high level language with assembly code, or mixing assembly code with the high level language, or inline assembly. So this video mainly focusing on assembly language. So the assembly language is the human readable notation of the machine language. So you know very well the processor understands machine language, which is ones and zeros, but the human cannot understand ones and zeros. So that's why the human understandable language is nothing but the assembly language. Okay, so we require a tool which translates the program which is written in the high level language to the assembly language. So that is called assembler. So machine language is the processor understandable language. So the machine language is the binary representation, and it consists of ones and zeros, you know very well. And the assembly language and machine languages are processor or controller dependent. So the assembly language programming is the process of writing the processor specific machine code in mnemonic form. Mnemonic is nothing but short form of the instruction, and converting the mnemonics into the actual processor instructions. So the general format of an assembly language instruction is opcode followed by operands. So opcode will specify the operation code. So that means suppose if you are allocating 4 bits for the opcode, so that means the CPU can perform up to 2 power 4 distinct operations. So opcode specifies the operation code. Operands are going to specify what type of operands that we need to use. So the operands can be either register operands or memory operands. So if an operand resides in a register, we call that operand as register operand. If an operand resides in a memory at one particular location, then it is called memory operand. Okay. So the operand can be either single operand, dual operand, or more. So example here, if you take 8051 microcontroller, an assembly instruction, that is MOV A comma hash 30H. Now here hash means immediate data. Hash means immediate data. So this instruction moves a decimal value 30 to the 8051 A register, that is called accumulator register. Here MOV space A is the opcode and 30 is the operand. Okay, so the same instruction when written in machine language will look like this. Okay, now so that is 0 1 1 1 0 1 0 0 0 1 1 1 0. So the first 8-bit binary value represents the opcode, and the second 8-bit binary value represents the operand 30. So that means 0. Okay, so the assembly language instructions are written one per line, and each line of assembly language program is split into 4 fields: label field, opcode field, operand fields, and comments. So label field is optional. Label means, so if you want to execute a set of instructions frequently, then you can use the label. Okay, that is optional. The label identifier is used extensively in the programs to reduce the reliance on the programmers for remembering where the data code is located. So label is commonly useful for representing a memory location, address of a program, subroutine, or a code portion. So the maximum length of a label differs between assemblers. So the assembler insists strict formats for labeling. Labels are always suffixed by a colon and begin with a valid character. The label can contain numbers from 0 to 9. And here, this is the process of converting the source file to the hex file translation, hex file. So the assembly language program written in the assembly code is saved with an extension .asm file or .src file. So similar to C, it is possible to have a multiple source files called modules in assembly language programming. Each module is represented by .asm or .src file extension. So the software utility is called assembler, which performs the translation of assembly code to the machine code. And the assemblers for different family of target machines are different. Okay. So the A15 macro assembler from the Keel software is a popular assembler for 8051 family microcontrollers. Each source file can be assembled separately to examine the syntax errors and incorrect assembly instructions. So the assembling of each source file generates the corresponding object file. So that means .asm file is converted to the .obj file. So the object file does not contain the absolute address where the generated code needs to be placed on the program memories. So the assembler converts the .asm file to the .obj file, but that file doesn't contain the absolute address. Here the absolute address is nothing but the address at where the object file needs to be placed in the program memory. So the software program called linker or locator is responsible for assigning the absolute address to object file during the linking process. So the absolute object file created from the object files corresponding to the different source code modules contains the information about the address at where each instruction needs to be placed in the code memory. And a software utility is called object to hex file converter translates the absolute object file to the corresponding hex file. So this is the block diagram that is showing. So multiple source files, you are giving it as an input to the module assembler. Each module assembler generates the object files corresponding here. So here, all the object files are linked with the library files. So that will be done by the linker or locator. The linker or locator generates the absolute object file, and this absolute object file is given as an input to the object to hex file converter, and this object to hex file converter gives finally the machine code, which is with an extension .hex. So this is about the assembly language, and which is the embedded firmware development, one of the embedded firmware development language. So hope you understand this video. So we'll meet in the next video. Thank you one and all.